You ready to hear about identity this morning? Were you all up late last night? You all from different time zones? Very good. All right, I need to take a quick roll call before we start. How many people here consider themselves IT professionals? IT professionals? Okay, that's probably 40% of the audience. Developers. How many developers? And by the way, do you know how the test for to tell if you're a developer? You might be sitting there going, I defy these categories. I'm not a developer. I'm not an IT professional. I'm everything. The way that I define it is if you have Visual Studio installed, you're a developer. So you should count that. Now let's do it. Developers. Okay, keep your hands up. How many people, developers that are working with like a software company, so you build software for a living, keep your hands up. Okay, so most of the developers were enterprise IT. You develop within your company. Is that true? Do this? Yes? Okay. All right. Well, for the people who are building applications, I have a simple question for you. How many of you believe you're going to be building a successful application? Hands back up. Really successful. All the developers should be raising their hands again. Otherwise, you have other issues that you might want to consider. I'd like to begin my presentation this morning with a quote. And this pertains to the developers in the audience. If you're successful, enterprise IT will require you to integrate your application with their enterprise identity management system. IT people, is that yes? Successful applications are meaningful applications, important applications. They have to be integrated with enterprise IT. And that's to help organizations control risk. It's to help them control workflow, productivity, make sure people lose their access when they're supposed to lose their access. Does anyone know where this quote comes from? Anybody? Well, actually, I just said it. But I think it's important, and in fact, because I work on Active Directory, and I've worked on Active Directory for a very long time, I'm actually going to amend this very slightly, because, as you know, Active Directory is a central part of the identity management systems for many large organizations. I'm going to say that if you're successful, enterprise IT will require you to integrate your application with Active Directory. Now, for many, many years, Active Directory has been around, and it's been a relatively straightforward proposition for how you integrate your application with Active Directory. However, there's a couple of things that make this more complex in today's day and age of modern applications, and that's if you're building a cloud application, if you're building a mobile application, if you're building a SaaS application, it's not really straightforward how you go about integrating your app with Active Directory, and that's what we're going to talk about this morning. My name is Stuart Kwan. I'm a program manager on the Azure Active Directory team, and I'm going to talk about how we view developers building applications now that integrate with enterprise identity management systems. And we'll do a little quick demonstration of how you do that for an example application. And what I'm going to try to do is be really particular about pointing out the points that make sense for if you're building software for a living and you're, say, building a SaaS application. And then also the relevant points for if you're building applications within an enterprise. And we'll do that, we'll get an overview of that, and then we'll look at some of the future things that we're working on, just a subset of them, things that we were ready to talk about this week to you. And at the end, we'll take questions, and I'll be here this afternoon as well in the expo area if you have further drill down that you'd like to do. But to begin, what we need to do is talk about this thing called identity management as a service. What is Azure Active Directory anyway? And how does this play into the enterprise environment that exists now? We'll look at some of the benefits of using Azure Active Directory as the way that you integrate, how you do it, and then futures. I've gone through that a bit already. So let's take a look at a typical situation before identity management as a service exists, and how we take applications, how we plug them into the enterprise identity management systems that exist today. So you can imagine the bubble that says your application. That could be a SaaS application. It could be a cloud application. It could be an enterprise application. It doesn't matter. When you go to plug your app into that enterprise identity management system, there's essentially two things that end up happening. One is you need to accept sign-ons from somewhere other than your own application. How many people here, and this is maybe a dangerous question to ask this audience because I think you're probably all building applications that do integrate with Active Directory today. But how many people here build an application that has its own, completely its own sign-in? Doesn't do anything with Active Directory? Nobody? Nobody? So a few. Oh, good. Your hands came up. No, you shouldn't be ashamed. You're the ones who stand to gain the most from this presentation. So everyone else will be old hat to a certain extent. But there's a couple of things you have to do with your app. First of all, you have to accept sign-in from another system. I'm going to call that federation. you might think of federation as something that involves the SAML protocol or OpenID Connect, but I view federation really just as a concept where you're accepting sign-ins from a third party. And that could be doing LDAP binds, it could be doing Kerberos, but you have to take sign-in and take it out of your app and put it somewhere else. That's one thing you have to do. If you're building a cloud application, then often this involves setting up SAML, and if it involves setting up SAML and things like that, there's a lot of esoteric parameters that need to be shared back and forth between you and the people running the identity management system, and it's usually not a straightforward thing. And it's difficult to just automate that setup process as well. Finally, there's a lot of applications that need to know more about the user than can be sent when the user signs in. They need to know the shape of the organizational hierarchy, the groups the user is a member of, other details of the user that aren't provided through just a straightforward authentication. So these are other things that you need to do, and often, even if you're building an enterprise application, that enterprise application needs to know when users are getting provisioned into the environment. So you need some sort of proactive call from the identity management system, and often that involves wiring up something very special. So how does the picture change when we add this thing called identity management as a service into the situation? So Azure Active Directory is identity management as a service. It literally provides identity management capabilities as a service out of the cloud. So if you have your application now, what you can do is you can take your application and you can accept sign-ins, and you can get information about users through the directory, and you can do things like provision users in your application based on using that interface against Azure Active Directory. Now, how this is different than just plain old Active Directory is a couple of things. Number one, it's in the cloud. So now, if you're building an on-premises application, you're building a cloud application, you can know that you can get to this data. Previously, if you were building a cloud application, it might be difficult for you to imagine, how am I going to get at that directory data that's inside the firewall of my company? Am I going to have to set up VPNs? Or if I'm a vendor building apps, like a SaaS app for many, many people, how am I going to imagine getting inside the networks of all of the different customers that I work with? And now you can depend on the data being in the cloud, and you can depend on it having a very particular, consistent interface, regardless, again, if you're a vendor, of who the customer is. The interface is always the same, and we're going to be able to automate the setup of federation as well, and I'll show that during the demo. So that's one thing. The other thing that happens here is the identity management as a service provides the essential connectivity from these on-premises systems that people have been building for all of these years. So the IT folks in the audience have been lovingly building up these automated provisioning and identity management systems, and what we need to do is make sure that there's connectivity to that thing in the cloud, to the service in the cloud, and we make sure that that happens at Microsoft. We provide synchronization capabilities, federation capabilities, and not just things like ADFS. We also allow people to use a wide range, probably about 24 different kinds of federation servers that they might have already, to extend their on-premises identity system into the cloud. Now, as we've been doing this, we've also been discovering that there's some huge benefits to having identities up in the cloud. Because now that they're there, we can do things like manipulate them. We can do, believe it or not, self-service password reset, even for on-premises identities, from the cloud. We can do self-service group management and user profile management from the cloud and have that information synchronized back down on premises. And that has some fairly significant benefits to people who run these identity management systems in enterprises, because now you can get these capabilities without having to deploy additional on-premises software. All of the capability can simply be centered in the cloud. And this is actually a trend that we're seeing amongst our customers, that they really are driving for us to push more and more of the authority for identity and identity management and application development to that hub in the cloud, because we can run it, Microsoft can run it, Microsoft can keep it up to date, and Microsoft will deliver a high SLA to it, and usually do that more cost effectively than people can do it for themselves. The same way that now people who use Office 365 and realizations that we've had in the past, that we can run email servers more effectively than you can run email servers, simply because we have the source code of the email servers and the people who wrote them, right? And we can keep those things running much more effectively in many cases than you can, because you're playing the game with one hand tied behind your back. The same thing can work with identity management systems. And what ends up happening is, with this connectivity between on-premises and cloud, we can manage this directory, this identity system, as a single hybrid system. It has a foot in the cloud, it has a foot on-premises, but it's logically managed as a single entity. So if you're a developer, what that means is, if you need to integrate your application with Active Directory, then it is equivalent to integrate your application with Azure Active Directory, because it's all one directory. It is the directory. If we could, we would simply refer to this as Active Directory, one thing, but often we need to refer to the constituent parts so you understand where you're pointing. Are you pointing at Active Directory? Are you pointing at Azure Active Directory? But that's the net story. If you're building a new application today, we encourage you, and we see many customers going to connecting their application to Azure AD instead of Active Directory. And a lot of that, again, comes from the cloud first, mobile first push that Microsoft in the industry is doing. So let's look at Active Directory a little bit by the numbers. Some of these numbers were mentioned in the keynote. They've come up at other presentations and conferences. But we have about 5 million, or more than 5 million now, organizations that are represented in Azure Active Directory. Why so many? Every Office 365 customer is using Azure Active Directory. This is actually a pretty important point. If you have Office 365 today, then you have Azure Active Directory. It's a factored out part of that system. It just comes with the purchase of Office 365. You don't need to go get a different Azure Active Directory if you're going to be doing development. You can simply use the one that's already in place for Office 365 or Dynamics or Microsoft Azure, whatever you might have already purchased. Or you can actually go get Azure AD separately if you just want to do development, for example. You want to build a development environment. But for a production environment, you can use what you've got for Office 365. It hosts more than 500 million objects today. As Satya mentioned a couple weeks ago, we have about 50 million active Office 365 users a month, which is a fairly large number. We service about 1 billion to 2 billion authentications a day, depending on the day, depending on the time of the time of the year. We watch the telemetry pretty closely, and we could see the surges as sort of seasonally things are happening. People are going on vacation, coming back from vacation. But between 1 billion to 2 billion authentications a day. It runs in 28 different data centers, so the data is near to the customer or near to the end user, regardless of where you are around the world. And we make sure that that a given tenant's data is replicated to at least 3 data centers. And we automatically do things like failover calls. If a call is going for one data center and there's a problem, we detect a problem in the network or a problem in the responses coming from that data center, we automatically reroute to the next near data center in the same region. So we have the ability to fail over data centers automatically. As it turns out, by the way, at least in my experience when I've been the on-call engineer, it's not usually software issues that bring this up. You'd be surprised how often fiber gets cut as people are digging in places, right? I just have this image in my head of backhoes. You know, the backhoe goes down and comes up with a whole bunch of glass on the end, and people are like, what's that? And that causes data centers to go offline, and we reroute traffic as that happens. Another thing that we can do with Azure AD is we can help users engage with your application, and if you're a vendor, we can also help promote your application by it being listed in various galleries that we have. So today, Azure Active Directory is integrated with more than 2,400 applications. If you squint in the screen there, you can see on the left-hand nav, there's an all 24, and when I took the screenshot, 2477 applications that are integrated with Azure Active Directory. If you're a vendor, you can also publish your application into this gallery so that people can find it, and they can easily adopt it just by clicking that button there that says sign up for your application, and that will get them through. And we'll show a quick demo of that when we get a little further. And this is coming soon, so that was the Azure Active Directory application gallery that an Azure AD administrator can see. There's also an Office 365 store that's coming soon where you can also promote your application there. So if you want to show up in the Office experience and you're building an application, then you can have your app there. Furthermore, if you are in the gallery or if you're in the store or if you're an enterprise developer and you've published your application and assigned it to users in your environment, then it shows up in their My Applications list, their Office 365 My Applications list, and in their Azure Active Directory Access Panel. There are these two places where we have jump-off points where you can get into an application. And if the user, and this is a neat point, if the user pins your application, then it will show up in their application launcher. So in the Office 365 experience, there's the waffle up in the top right-hand corner. And when the user clicks the waffle, they see all the different applications that they have, including the Office apps. And if you pin an application, it shows up there as well. So this can help drive engagement with your app. If people have a hard time remembering and finding it, maybe they only use your app once a month or once a quarter, but it's very important that they're able to get to it, and you want to help them, guide them to it, then you can they can pin the application into their launcher. There's also these advanced security monitoring benefits that Brad talked about in the keynote yesterday, and I'm going to very quickly go through here. And what I'd like you to think about as we're going through these things is, if you're just integrating with Active Directory on premises, there are many of these things you can't get at. The reason why a lot of these monitoring benefits exist is because we can run the machine learning in the cloud, is because we can look at the telemetry that's coming from those 1 to 2 billion authentications a day. So here's just a sample of the sort of things that we look at and reports that administrators can get. We watch in the background for an attack where someone is trying very slowly and steadily to guess a user's password, and they're doing it slow enough that it's below the threshold rates for locking a user out. But they're trying bad passwords, but then if they actually get it right, then we can detect that in the sequence and go, hey, that might be a brute force attack. So we'll signal that a successful brute force attack might have just happened. We'll signal the administrator on that. We also look for sign-ins that are coming from anonymizer networks like Tor. If someone is behind Tor and trying to sign in, maybe they're trying to cover their tracks of an attack sign-in. So we watch for those, and we signal sign-ins for users, and we'll tell you what user it was, who might be trying to, or you might be under attack from the other side of an anonymizer. Brad talked about this yesterday. The unlikely travel case is the easiest one to sort of conceptualize. I have a user who signed in one place, and then a very short period later signed in a very geographically distant place. So either they have some form of transportation that's only available to very few people, like either they're Elon Musk or an astronaut, or it's unlikely that they were actually doing this, right? That they could actually do this sign-in. So it's probably an attack, and we signal that to the administrator as well. And that's something that has been done for years, for example, in the credit industry, looking for a credit card being used very rapidly between two very distant locations. And then finally, because we have this multi-tenant, worldwide deployed system, we can look at patterns where, say, a particular IP address has tried bad passwords against many different users in many different tenants. What are the odds that that's an attack? Well, that's another thing that we can signal. And this is something, again, it's very difficult for us to imagine providing this kind of capability directly for an on-premises system because you just don't have all of that data in your hand at the moment. Whereas in the cloud, we have this data in our hands. And then finally, we do a lot of work, as you know, at Microsoft, detecting malware, watching for botnets, cracking botnets. And when we find botnets and we've determined that they are really infected devices, then our digital crimes unit shares the IP addresses of those with us so that we can signal if we see sign-ins coming from known infected devices. That could also be an attack. And then yesterday as well, Brad mentioned a capability that we have coming soon where we actually track, because we have a fairly significant security team, we track cases where whole sets of users' names and passwords have been dumped out into paste bins and stuff like that, that are the result of a successful attack where this stuff is being either dumped out into a very well-known paste bin or being dumped out to a place in the corners of the web where organized crime is operating. And we will compare that with lists of user accounts we have to see if any of those match up, like maybe it's the user using the same username and password in multiple places, or maybe the stuff has been stolen from us. We have to watch out for that as well. And then we can tell you, oh, look, we have reason to believe that these accounts of yours have been stolen, their passwords have been stolen, and that you should go and change the password on those accounts. So we'll signal that as well. That's a thing that we have in progress. So that's security monitoring benefits, promotion benefits, the fact that you're plugged into an enterprise's identity management system so that you're adhering to corporate policy. I'll show a little example of that later. So that your users don't have to remember another password to get into your system. Another benefit is Azure Active Directory, in its essential form, with the sign-in service and the directory services, is absolutely free. So if you're doing development, or even if you're going to go into production, you can get Azure AD and you don't have to spend any extra money for it. We do have a set of additional offerings for Azure AD that have the advanced identity management capabilities. So things like the self-service password reset out of the cloud, self-service group management out of the cloud, the ability for that to be written back to your on-premises system. Those are premium capabilities that we do charge for. But the essential directory capability, the essential sign-in capability, it's all free. Okay, so you're building an application, you want to integrate it. How do we do that integration? It's really three relatively straightforward steps. It involves, and the first part is where most of the magic is really. If the directory knows about your application, then it can do things for you. So the first thing you need to do is register your application with Azure AD. If you've ever built a Facebook application or a Google application or a Dropbox application or any of those, then you're familiar with this process where you have to go to the app console for that vendor. For us, you have to come to the Azure AD part of the Azure portal, and you get a client ID to represent your app. You get a secret if you need it, depending on the kind of app you're building. You register this set of things called redirect URLs. That's where it's safe for us to give a token back to your application. You have to tell us where it's safe. And then if you're going to call any of our APIs, like if you're going to call the directory through the Graph API, then you need to tell us what permissions your application needs that it's going to use when it accesses those APIs. Once you're registered, then you're going to add some code to send sign-in requests, process the responses when they come back. What you get back is a token. You need to verify the token came from Azure AD, and then extract out the information about the user. If you're going to call one of our APIs, then you're going to get back this thing called an authorization code, and you're going to redeem that for another token that you can use to call the APIs. And an API you could call, for example, is the Graph API, so you can read more information about the user from the directory, read information about the organization, get the user's group memberships, update the directory, all through the Graph API. That's an example of a REST API that you can call. And then the Office 365 applications also now have a large suite of REST APIs, so you can do things like read the user's schedule, add things to the user's calendar, check their email, etc. You can do all of those things. So 3 straightforward steps. Let's look at what the protocol sequence looks like, and then we'll open up an application and we'll see it in action. So what we have here is a sequence diagram where I have a person sitting at a browser, and they're going to access a web application, and Azure AD is in the middle. Initially, when they go to the application, they're not signed in at all. So you navigate your browser to the app, and how can we tell, by the way, with a web application, that the user isn't signed in at all? Anybody know? No token. They didn't present a token. If they'd already presented a token, what also happens in the sequence? How do we represent session state in a web case? A cookie, yes. So there's no cookie being presented to the website. So the website says, you don't have a session. I'm going to send you off to be authenticated. And maybe the user has to press a button, a sign-in button or such, in the web app to get that sign-in to happen. And what that actually generates is a sign-in request that you send to Azure AD through the user's browser by giving a redirect, a 302. And that causes an OpenID Connect we're going to talk about in this particular case, although this sequence works for other protocols as well. It's roughly the same. We generate an OpenID Connect request. And now the user signs in. And a bunch of stuff happens between the user and Azure AD in these steps that you as the application don't get to know about, you don't care about. Maybe it's going to ask me questions. Maybe it's going to ask for a name and password. Maybe it's going to prompt me to do a 2-factor sign-in, whatever. All those things happen. And then finally, Azure AD is going to, via the user's browser, send the response back to you. And that will come back, in most cases, in the case that we recommend you do, as a post back to your application with a token in it and the auth code, these two things. The token you use to recognize the user, and so we look at the token. The token is signed with a signing key from Azure AD. We make sure that it's signed properly. We make sure that the details about the user are what we expected. It came from a tenant we expected. It is the user we expected. And then we can move on, and we can set that cookie on the user to create the session state. From now on, when the user visits the application in this particular session, they're presenting that cookie. And that's a detail that you can take care of in your application, what's in the cookie and how long the cookie lasts. And then finally, since we got that authorization code, and this is part of the OpenID Connect /OAuth protocols, which I'll discuss in a little more detail in a moment, we can take that authorization code and we can redeem it for tokens that we can use to call APIs. We get 2 tokens back. A token called an access token, that's the one you're actually going to use, attached to a call to a REST API, and this thing called a refresh token. A refresh token can be used to get more access tokens to call either different APIs or in case the access token you have runs out. It expires and you need to get a new one. And then you can get a new token for that user without the user being present. So later, after the user has departed, you need to do something on their behalf. You can use the refresh token to get a new access token and make those calls, for example, to the Graph API. You can almost think of the refresh token as a very limited sort of TGT in the Kerberos sense, like a ticket getting ticket. OK, so that's the essential sequence. Yeah, go ahead. Can Azure AD do custom claims? What I'm going to show in the demo next, is what claims you get from Azure AD. And we're actually working on a feature where you'll be able to adjust the claim set that you get from Azure AD, but it all has to come from stuff that's stored in the directory. We will today, so the question was, can I have an external claims provider? Can I get claims from another source when I'm signing into Azure AD? Today we don't have that capability. It's something that we'll look at if people ask for it. It is difficult in the cloud system because we need to keep everything very fast. And if we have these outside dependencies, it can be difficult for us to make that happen. All right, so what I'm going to do is I'm going to show an app. And this app, by the way, is in my GitHub repo. If you're familiar with GitHub, and it's very difficult to read on the slide, github.com/squan. And what I've done is I've forked one of our main samples, and I'm showing how to build this application here in the sample. I have to unlock my machine, of course. OK. So on the screen, to begin, I have the registration of this application. Now, the scenario you're about to see is as if a vendor, a SaaS vendor, was offering an application to many, many different companies. The exact same code, almost exact same code applies if you're building an enterprise application. I'll point out the one difference that's there, or there's 2 differences, one in the registration and one in the code. So we have an application that I built here called To-Do List Reimagined. I ripped that name off from Vittorio Bertocci. Thanks, Vittorio. The application, of course, is then known as TDLR. Did you see what I did there? TDLR? Easily mixed up with anyway. So TDLR. The sign-on URL of the application is where the user will be sent if they click you in that application launcher. So this is the URL they'll be directed to if they launch out of the app launcher or the My Apps list. Here we have, you can upload a logo so that you show up nicely in the store and the gallery. In this case, this application is multi-tenant, which means it can work with any Azure AD user. It's not restricted to this, to being used in this particular tenant. If you're building an enterprise application just for your own employees, you would not move this switch to yes. You'd leave it in the no position. There's the client ID that needs to go in the code to identify the app. And this application has a key as well. It has a secret because of the particular OAuth grant type that it's using. And then if we look here, here are 2 reply URLs that are safe to send tokens back to this app. One for TDLR running in Azure websites, which I'm going to show, and then another for the local debugging I'm doing, because I want to be able to do both of these things at the same time. If I only had, I could only have one. It could just be for the production app, and that would be OK. But then I wouldn't be able to do debugging locally and run the app in the cloud at the same time. So I've registered both. And then finally, this application asks for 2 delegated permissions to call Azure Active Directory. Delegated means it's going to make these calls on behalf of the user that has visited the application. So the user's going to visit the app, and then the app is going to call the directory as the user, and when it does so, it's going to have these permissions. It's going to be able to, the essential one here is enable sign-on and read users' profiles. That's the minimum you have to ask for if you're going to sign users on with Azure AD. And then this one also does read directory data because it's going to have a people picker in it where I can search for users in the directory. So it asks for these 2 delegated permissions. All right. Then let's actually look at the app. So over here, I have TDLR, and I've added 2 buttons to it. One button is just to sign in. Another button here is to sign a whole organization up for the application. And again, this is you have to imagine this is a SaaS application, and I'm going to streamline the sign-in process and that whole federation setup process through this one link. Now, as it turns out, because of the set of permissions that we have available for Azure AD today, I have to be a tenant administrator to use this particular button. And that's because today, only a tenant administrator can consent, I'll show this in a moment, can consent to allowing an application to read the directory because of the amount of information today that you can get when you have that read directory permission. We're adding some new permissions, and they just didn't make it this week. We hope to have them out last week and then this week, so it'll probably be next week, when we have a set of new permissions out that an ordinary user could consent to. So an ordinary user would be able to say, yeah, it's okay, I'm okay with this application being able to read the directory because it'll only be able to read a narrow, if you will, vertical slice of the directory of users and groups, some of the information about users and groups. So you could build a people picker sort of thing. But today, if you were to build and run this application, I have to be a tenant admin to sign my organization up for the app. But let's go ahead and do that. So if I click to sign up my organization, now an OpenID Connect request has been sent to Azure AD, and I see the sign-in page. I'm going to sign in with a tenant administrator, and this is for my tenant here, Squantoso. When I see what I did there, I'm particularly proud of that name. Silly me. When I tabbed out of the field, you saw that the Squantoso custom sign-in page has loaded, and then I'm going to enter my password. Okay, this is the consent step, where because I'm signing my organization up, I have to say it's okay for this application to be able to read directory data and also sign users in. If I cancel here, then the situation is aborted. If I press accept, then effectively I will have federated this application with my tenant, and now other users can sign in. So there was no exchange of exotic parameters or anything like that to set up the federation. Now my end users can sign in here with single sign-on with their Azure AD accounts. I'm all done. That's what it took to get that set up. All right, that's great. So let's show that. We'll sign out of my administrator account. We'll sign back in with a different user account that's just an ordinary user. Use another account. My alternative account, squantoso.com. And when I sign this user in, there's no consent step. Right? Before we saw a consent step. This time, because the administrator said it's okay, everyone can sign in. If you're building an enterprise application and you register that application in the tenant as a directory administrator, as a global administrator, then users will all be able to sign in, no consent is involved. If you're an ordinary user in a directory tenant and you register an application, other users who want to use that application will be asked to consent to that application. Because who knows, some ordinary person of the unwashed masses has registered an app. Now other users get a chance to say, well, I'm okay with this application seeing this information about me or seeing my calendar or whatever, or I'm not, and they can say no. If an administrator sets that up, then they can make that decision on behalf of all users. Let's take a look at the information that we get about the user. Here on the About page, we've modified it to show the set of claims that come from the directory. Here it's sending group claims, so we can see that Alt is a member of the engineering staff group. And it also sends things like, here's the tenant that the user has come from. That's the tenant identifier for Squantoso.com. The reason why we have a tenant identifier like this is the name Squantoso.com was associated with this tenant by me proving that I own the DNS for Squantoso.com. But I could associate other names. I could remove these names. This name will never change and never be reused and represents that particular tenant. We can see the user's sign-in UPN and first name, last name, not very creative, alternate user. And then a display name that you can use if all you have is access to that name claim. We have the user signed in with a password type strength. And what else? Anything else interesting? Oh, here's how long in seconds before my password's going to expire and where the user needs to go if they want to change their password. This allows an app to show a little toast. Oh, your password's going to expire soon. If this falls, say, within 2 weeks. Your password's going to expire within 14 days. You can click to this link to change your password. As you might have seen inside OWA or such or SharePoint when you signed in, it can warn you about these things. So that's the essential set of information about the user that you get. This is a task application, and what it lets me do is add tasks, and then I can share them with other people. So let's say finish Ignite demos, the task I'm working on. We'll add that task. We'll go to share it with some people. There's a field up here that says search for users and groups. And behind that field, where I'm actually going to be able to search the directory, because there's JavaScript behind that field that's going to make REST calls to the directory to search. Let's start Fiddler and run it in the background here so we can see what's happening. OK, Fiddler's up. So if I go here and I just type into the field, or tap into the field, automatically it's going to go just grab a bunch of users, the first set of users in the directory, and show it so I can start to navigate if I want, just to browse. And OK, well, let's actually take a look at what happened there. If we look at the query to graph.windows.net, which is the graph endpoint on Azure AD, we can see that it's doing a search for this tenant. Remember, that was the tenant ID of squantoso.com. And the user is, or we're looking for users, and we just grab the top 7 users. And if I look at this next one, then I'm looking for groups and the top 7 groups. And I then get some, if we were to look at the raw response here, or the JSON response, then we get back a hunk of JSON that has all of the lists of groups, like here's the engineering staff group, for example, and the details about the engineering staff group. If I were to do something like a type down, so let me find all the users whose names start with Stu, then we can go back here, and again, we'll look at the query, and you can see, when we crack this one open, in fact, I have an example here, example graph query that I've blown up a bit again here. So we have, looking in the Squantoso tenant for users, find the top 7 with a filter where name starts with Stu, or given name Stu, or surname Stu, or et cetera, user principal name, et cetera. Very simple query to create. And then again, back comes a hunk of JSON that has the list of users that qualify for that. If we come back here, by the way, Stu Rocks, that's my, I don't know how I got that in there in my tenant. That's my Xbox Live username. So if anyone here plays Wordament, anyone play Wordament? Look for me on Wordament. I play it a lot. But anyway, little plug for that, a lovely little game. All right, and let's share that task. Oh, I didn't actually select someone. So let's share that task with Stuart. And we can go back to the tasks. Very good. So I'm going to sign out of this user one more time. Let's show some stuff that we can do where we can reflect how now the administrator, because we're using Azure AD for sign-in, now the administrator has control over who can visit this application. We'll go back to the, this was, by the way, the Azure portal, the Active Directory section of the Azure portal, where I was showing the registration for TDLR. This registration is in the tenant that was building the to-do list application. Let's look at the tenant where it got registered. So this is Squantoso Corporation. And we can look at the list of applications in Squantoso, and we find To-Do List Reimagined is one of the apps that's here. And we can see information like the number of unique users and sign-ins over time on the dashboard. I've been doing this demo quite a bit lately. If we go over to configure the application, we can do things like set access rules. So here, this set of access rules says, oh, we can require users to do multi-factor authentication. We saw this in the keynote yesterday. Or require multi-factor authentication only when the user is not on a designated set of IP addresses that represent the corporate network. Let's go ahead and set this. Let's say that we'll have a group, and we'll just pick the engineering staff group. Just barely get that button there. So now users in the engineering staff group are going to require multi-factor authentication. If we wanted, we could put an exception in here as well, like, except for this other group I have, which represents users that have forgotten their phones and they're traveling or their phone is broken, and I need to let them not do multi-factor authentication because of that. So help desk maintains this group over here of people who are allowed to skip through it. But I won't set the exception. I'll just say multi-factor authentication is required. I'll flip that on, hit save. Okay, so now users who visit this application, the to-do list application, need to do multi-factor. And if I go back to the app and I go to sign in, and I go to sign in with Squan, who's a member of the engineering staff group, and enter my password. Okay, so now I'm being prompted to do multi-factor. I didn't have to change any code in the app. I actually didn't have any code in the app to know anything about this. I go over to my phone, unlock it, answer the notification. So in this case, I have a multi-factor authentication app, an authenticator app that I've downloaded onto my phone. And I just have to press verify, and there, I'm signed in. So I did multi-factor auth. And that's an example of one condition that we have. Go ahead.
So this access rule that you just set up, does it only allow the engineering folks to sign in, or when the engineering folks sign in, they have to do multi-factor auth, but everyone else can still sign in?
So the question was, if what happened there? Was it only engineering staff could sign in, or only the engineering staff has to do multi-factor auth? It's the latter in this case. Only the engineering staff has to do multi-factor auth. The reason why we have that is maybe there are cases where you want to say, well, administrators, they always have to do multi-factor auth. Or maybe you're just rolling out the process of multi-factor auth to this app, and you're piloting a set of people, and you didn't want to turn it all on at once because if thousands of people visit the app every day, and all of a sudden, they're all getting this new prompt, and it's breaking for some of them, this lets you do it in a controlled way. Now, we actually have another setting that we're working on. It's not all the way there yet, where you'll be able to say only users assigned to this application will be able to sign into it. And there's another place in the portal that you go to set who's assigned to the application. And you can actually do things like assign them roles, and then the roles can be sent as claims to the application. And that's all driven through the administrator doing that management in the portal. Okay, the last thing I'd like to do here is show some of the code of this application. So remember, it was set up both for debug and for that full running version that's on the that's an Azure website. So here's the app, and I'm just going to hit F5 here to start it running. I've set some strategic breakpoints here so we can go through the process. Okay, the app is coming up to run. The very first thing that's going to happen is the app's going to set up the pipeline, the authentication pipeline for the application because of the code that I've written. This application is using OWIN, the OWIN pipeline from the Katana project, as the pipeline that does where you can put middleware processing in front of the application. We have a middleware for OpenID Connect, and that has been added to this application as a NuGet. And there's this file right down here, this startup.cs file, that there's a specially named file that you put in place that initializes the OWIN pipeline. Inside that startup.cs file, we have this class for startup, and we have the configuration routine, and we run this particular method called configureauth. Now, if I just hit continue, then we're going to jump to that configureauth. Configureauth is in this specially named file, startup.auth, and here's the configureauth routine. The first part of it is going to initialize the cookie authentication module. This is the module that does the setting of the session after the user is properly signed in. And it cooperates with this next piece of code here, use OpenID Connect authentication, which loads the OpenID Connect middleware into the pipeline. We have to tell that middleware what the client ID of the application is. We also have to tell it, which I'm loading out of webconfig, and we also have to tell it which Azure Active Directory it's working with. Believe it or not, there's more than one Azure Active Directory instance in the world. Today there are two. There's one that's for all of Office 365 and public Azure. And there's another one in China that has the China Office 365 and the China Microsoft Azure installation. Most of the time, the authority that you're going to be using is the public one, login.microsoftonline.com. We'll see that in a trace in a moment. So this sets up the pipeline. If we hit continue, then the application will finish loading up, and it'll be all ready to go in just a moment as it's being built. Okay, and then if we click sign in, The code behind this button is in this account controller here that we've created. And here's this is an MVC app. Here's the routine for handling the sign-in. This piece of code here is what sends the OpenID Connect request. So you get the OWIN context authentication challenge, and we're going to send the OpenID Connect challenge. If we go ahead and hit continue here, we'll see the request. We'll actually land up again on the sign-in page because I press sign-in. If we go to Fiddler and we take a look here, what happened? Here's the call to login.microsoftonline.com, and here's what the OAuth, what the OpenID Connect request looks like. I've already built one of these, and we can explode it here. So we're sending that request, if you remember from that sequence diagram, to the authorize endpoint on Azure AD. So the OAuth 2 authorize endpoint. This, by the way, would normally have the name of the tenant in it, because we're going to login.microsoftonline.com/tenant name or tenant ID. But because this is a multi-tenant application, we don't know where the user's from a priori. They haven't signed in yet. So we send them to this special place, this special moniker called common, to have them sign in. Here we have, in the request, we sent the client ID of the application. We want the response to come back as a form post. The response type is I want an authorization code because I'm going to be making those calls to the directory. And I want an ID token, that is the claims about the user, that comes back to my app. The scope is OpenID, and this is right out of the standard. I need to say OpenID, and I need to say profile if I want that ID token to have user information in it. State is information that the application can set, and it will always be returned back to it in the response. And this is something that web apps use to remember where the user was in the application when they were sent to sign in, so that when this comes back, they can remember where to put the user, so they can return to whatever they were doing in the app. And then again, here's that redirect URI that says, for this particular request, because there's multiple redirect URIs for the application, send this response back to localhost account sign in. You'll remember localhost colon 44322 was one of the redirect addresses that was registered for the app. If there's multiple redirect addresses, then you have to send the redirect URI so that the Azure Active Directory can verify the redirect URI you have sent is in the list, and okay, I can send the response back to that one. All right, so that's the very basics of a web application, in this case an MVC application that does sign in with Azure AD. We ran the application, the user got federation set up, and they got single sign-on, and they queried the directory. All relatively straightforward. Now we can go back to the deck. Oh, everything that you saw. Okay, so what did you see there that was out of the box free and what was premium? So the ability to sign in and read the directory, that was all free. When I went and I set those rules that you needed multi-factor auth, that was a premium capability in my tenant. So you can't set that if you only have a free tenant. By the way, one other thing that I want to mention. That was just one of many conditions that we're creating to allow IT professionals to control access to an application. Now imagine if you were building an application, for the developers in the audience. Imagine you were building an application and your customer came to you and said, by the way, so many people are accessing this application from their mobile devices now, and it's really important now because you guys, everyone in the audience here only builds really important applications and has really valuable corporate data in it. So what I want you to do is block all access to the application unless the user is coming from a non-jailbroken phone. And I'd like you to think for a moment about, okay, well, how would I do that? Oh my goodness, that's not straightforward. Now, as it turns out, with the combination of Azure Active Directory and Microsoft Intune, we can actually make that work. So that if a user opens their application and goes to sign in, when they get to Azure AD to sign in, we'll actually challenge their device to see if their device is registered in the directory. If it's not registered in the directory, we'll make them enroll with Intune and get registered in the directory. The Intune agent will check and see if the device is jailbroken. It will update an attribute on the directory saying that the device is not jailbroken. And then when the user goes to sign in, that will all get checked and they'll be able to sign in. If the device is jailbroken, they'll be blocked and they won't be able to sign in. That's a capability that we're building to help IT professionals manage risk and security in their environment. If you're building your own sign-in system, that's going to be really difficult for you. It's not It's not that straightforward, but we're putting all kinds of energy into doing that. And that's one of the reasons why we think it's very valuable for you to integrate with Azure AD. So the capability to do conditional access based on device state is something that we're working on right now. So it's soon or actually becoming available if you use Office. So if you're an Office 365 customer, you will get this capability through the Microsoft Intune for Office. If you want to use it with other applications, you will need the premium tenant from Azure AD. Go ahead. So the question is, when the ID token comes back, or if you get an access token on an API, does it get turned into a principal? If you use our libraries, like the OpenID Connect library, it automatically grabs the token, verifies the signature, makes sure that it has the right keys to do that, turns it into a claims principal, and gives you the claims. It does all of that for you, so you don't have to do that yourself if you use our libraries. And of course, and I'll talk about libraries in a second. It's all standard protocol, so you don't have to use our libraries. But we do recommend you use our libraries because we've gone through all the nitty-gritty of the security state of the code and everything, and we recommend you just pick up from all the work we've done. Now, as it turns out, people building applications today are building all kinds of applications, not just web applications. They're building native apps on PCs or mobile devices that call web APIs. Often what's happening is the logic for the application is dropping down into this web API here in the proximate middle of the screen. The web app is just a presentation layer, if you will, for people using browsers. But otherwise, server applications, native applications are calling the web API. All the logic is there. Often, the web APIs then call other downstream web APIs. And when they do that, they need to retain the user's identity as they're calling that downstream web API. As an example, there's a company that we work with called DocuSign. DocuSign builds an electronic signing application that can be on your mobile device. And what they have now in their app is the DocuSign app calls the DocuSign web API. Then the DocuSign web API calls SharePoint, so it can pick up a document off SharePoint, pull it into the signing app, sign it, and put it back on SharePoint. The only way that's going to work is if SharePoint thinks the user is calling SharePoint, right? So we need to be able to preserve the user's identity as we come down to the next web API. The way that we do all of this is through a set of protocols that are mainly strategically OAuth 2.0 and OpenID Connect. And if you've studied OAuth 2.0 and OpenID Connect, you'll learn that OpenID Connect is just this relatively small extension upon OAuth 2.0. So it's really the same suite of protocols, if you will. Now, because SAML 2.0 is very popular, and because WS Federation is still quite popular, especially amongst the Microsoft coding audience, we also support those in the browser interaction. But our strategic investments are all happening around OAuth 2.0 and OpenID Connect. And we can do all of these interactions today with Azure AD. We can do the web sign-in. We can do the calling of the web API from a native app. We can do the calling of a web API from a web app or from a web API. And we have samples that show you how to do all of this using our libraries. If you want to learn more and drill down into building these sorts of applications, Vittorio Bertocci has a talk on Thursday of this week. Vittorio, I saw you coming. Yes, there's a thumb coming from the back of the room there. Thumbs up for Thursday. And he's going to go into much more detail than I am about how you would build such applications. The reason why, one of the core reasons why we do OAuth 2.0, one reason we do OAuth 2.0 is, by the way, I should mention, it's possible to do OAuth 2.0 from a wide variety of platforms. Basically, all you need to be able to do is HTTP requests, serialize some JSON, and do a little bit of crypto, and you can do that. And you can do that from an iPhone, from an Android phone, from a variety of, like in IoT scenarios, you can do it from fairly small constrained devices. Often they all have these capabilities. So that's all you need to be able to do to implement this, as opposed to LDAP and Kerberos, which are a little bit more sophisticated, and you pretty much have to have libraries in order to make that happen on those platforms, where if all you have is raw platform capability, in many cases you can do OAuth, you can do OpenID Connect. One of the reasons why we really like using OAuth 2.0 and OpenID Connect is the sign-in experience is always a web experience. Whether you're coming to a web app in the browser, or even if you're using an app on a phone or a PC, the sign-in experience that comes up is always a web experience. And that lets us have an arbitrary conversation with the user when they sign in, so that we can do multi-factor auth, so that we can do consent, so that we can maybe put up questions to ask the user if they've tripped one of our anomalous sign-in detection mechanisms, or maybe we need them to reset their password or what have you. We can have that all happen. An arbitrary conversation can happen in that web channel, and we don't have to change the code of the native application at any time if we introduce these new interrupts. They all just happen in that web window. Now, we also have other ways you can authenticate to Azure AD. You can directly send Azure AD names and passwords, for example. And that's necessary in some environments where you just don't have any kind of web browser available to you or any kind of web view control. But those mechanisms will fail if the user needs to be interrupted. If there's some sort of interrupt, if a multi-factor auth needs to happen, it's just not going to work. So they're not as reliable. And we encourage everyone who's building applications to use the web-based mechanisms for the sign-in, unless they are absolutely sure none of the interrupts are going to happen. So the question was, in the non-interactive authentication mechanisms, do we support certificate-based auth? So we actually have, there's two different scenarios. One scenario is I have an application that has its own identity. You remember the app that I had both a client ID and a secret. If an application can authenticate with an X509 certificate. A user today can't authenticate with an X509 certificate, and that's something that we're working on. And it's very high on our priority list, so that there are certain situations where there are users who have nothing but a cert to log in. In some industries, it's popular for users to have nothing but a smart card. They don't even know their password. And we need to be able to support those sign-in mechanisms, and we're working on that right now. As it turns out, it's not as straightforward as it looks, because we need to do the certificate authentication in the web view. And on a mobile device, like an iOS device or an Android device, up until now, it's not been possible to do cert-based auth, to do like client TLS in a web view. It's just broken. In fact, it only just started working in Android L, and it only just started working in iOS 8.3. So in the newest version. So the other thing is, when you do this, you're going to need like the latest version of the OS on these mobile devices. On Windows, of course, it has always worked. Any idea on the ETA? I would say that it's, where are we at? We're in May. So I'm hoping that we get it done by the end of the calendar year, or it might leak a little bit into the beginning of next year to get this cert-based auth capability in place. But we're already hard at work on it. The directory. I talked a little bit about the directory. The directory, again, is just, or the Graph API is just a REST-based way to get access to data that's in the directory. You can see the organizational hierarchy, you can see users and groups, the details about users, just using regular, ordinary HTTP mechanisms. And you can get search semantics through OData, the OData syntax. It's an OData v3 compliant REST API, so you can do things like that $ filter that you saw in the query. And we're adding v4 support as well relatively soon. We have libraries that can help you do these queries, but equally well, as opposed to the authentication bits, if you want to just send HTTP requests and handle the JSON response yourself, it's very simple and straightforward. You can do that. Or you can use the libraries. We have libraries for a variety of platforms. And we have this really cool API reference where it's an interactive API reference. It shows you the whole URL of the query that you're about to do, and you can press a button and it'll show you the whole JSON response, and you can practice and try out all the different kinds of APIs against some dummy data. And I'll help you find these URLs later as well. This is a simple way to get to it. We have a wide variety of these authentication libraries, both for if you're building a native client or a PC or mobile client, or if you're building a server, including for iOS, Android, and the multi-target platforms like Xamarin and Cordova. And that, for the client side, is this thing that we call the Active Directory Authentication Library, or ADAL. On the server side, we have the OWIN middleware, as I mentioned earlier. We also have some work for Node. We need to do a bit more work on the server side. We're going to add Java server libraries as well, and probably some more over the course of the next year or so. These libraries are already in use by really big applications. So if you've downloaded onto your iPhone or onto an iPad Word, Excel, PowerPoint, or the OneDrive client, and when you sign in, it's using this ADAL library, the ADAL library for iOS, for example, and on Android as well. Plus, we've made all of these libraries open source. So if you want to take the source yourself and put it in your application, you're absolutely welcome to do so. If you want to fork it and contribute back, you can absolutely do that as well. They're available under the Apache 2.0 license, and you can find all of them at github.com/AzureAD. All right, let's talk about the future. Oh, and I'm running a little longer than I thought, so I'll go quickly through the future. Key Vault is a capability that we recently put into preview. Key Vault is about helping people with the hygiene of their keys. So anytime you have identity, you have secrets, and especially applications have secrets. And you can imagine if you have today, you're building a cloud application and it uses, say, Azure Storage, then you end up with storage keys in your source code. And that means that all of your developers and all of your operators can see these keys, and that's not the best situation to be in. You'd like to find a way to get or to minimize the number of people who have access to these keys. Another thing that can happen often is applications need to encrypt data, and often they do encrypt data today, but they encrypt it to keys that are owned by the developer. And especially in a case where you're a software vendor building an application, there will be customers who will come to you and say, I need you to encrypt my data to my key that's under my control. I can't just have you encrypt the data to a key that's under your control. So Key Vault is going to help with that. And the way this works is all the keys get stored in the Key Vault, and the way you get at the keys is by authenticating to Azure AD and getting a token for Azure AD and calling the Key Vault to either retrieve keys at runtime or to ask the Key Vault to do key operations for you. And all of that access then is very carefully monitored so that you can tell who accessed a key and when. And if users or applications are revoked from Azure AD, then they won't be able to see those keys anymore. So let's take a look at two quick scenarios for this. The first scenario is, imagine I have a bunch of storage keys in my app, and I just want to get them out of my source code. How can I do this? Well, what happens is, at design time, the developer creates a Key Vault, and the person who does know the storage keys, and it doesn't have to be everyone anymore, uploads all those keys into the Key Vault. Then the application that's going to use those keys, you have to register it in Azure AD. And of course, when you register the application in Azure AD, it is going to need a credential as well. So we'll create a certificate. And we'll associate that certificate with the application, and we'll upload it into the project in Azure. And then we'll just throw that certificate away. We don't need to store the private key at all. So now the system knows about the application, and the application has an identity. And I'm going to grant that application, that identity of that application, access to the key in the Key Vault. When the application starts now, it can authenticate to Azure AD, get a token, call the Key Vault, and ask for the storage keys, and now it can access storage at runtime. And none of the storage keys need to be in the source anymore, and neither does the certificate that was used to authenticate the app. That private key, that can all be thrown away. So now you've managed to reduce the surface area of people who know those storage keys quite a bit. So the question is, so what is the Key Vault? Is it... It's two things, actually. So there's two offerings in Key Vault. One is where it's software-stored keys, and another is where there's hardware-stored keys. And the hardware-stored keys are especially interesting in this particular scenario. So we do have HSMs running in the cloud as a service. And that's where, let's say that you have an application, and you're a vendor. You sell this application to many people, and your customer says, I need you to encrypt the data to my key, and not to a key that you've created. And how are we going to make this happen? So the way this works is, first of all, the customer creates a Key Vault, and they're going to get their key into the Key Vault. Now, as it turns out, if you want to use the hardware-based mechanism, you can actually come to us. So you come to Redmond with a suitcase with the key. And in a very carefully monitored scenario, we put the key into the hardware device. You're the only one who's ever seen the key. We never saw the key. It's now in hardware. It's dipped in amber, and it can't come out. And now the key is in there, and let's say, and then the customer will then grant your application, which is, you've built a multi-tenant application, registered it in Azure AD, and they will grant your application access to that encryption key through the HSM, through the Key Vault. Now, your application isn't going to encrypt everything with that key. That would be too inefficient to ask the HSM to do all that work. So what your application then does is creates a set of encryption keys. Follow me here. And it calls calls Key Vault and says, encrypt these encryption keys for me. So now the application has a set of encrypted encryption keys that it can store. And when it now needs to do work on the data, it can pick up an encrypted encryption key, send it to Key Vault and say, decrypt this for me. Key Vault gives back the decrypted key, and now you can do work on the data. But at rest, everything is encrypted. The encryption keys are encrypted, the data is encrypted, and the only way to decrypt that is to call the Key Vault, and the key is stored in the HSM where it can't get out. And this is a very interesting scenario, and we're working on using this within Microsoft. A couple more points. Actually, I'm going to hold questions now till the end because I only have 10 minutes left. ADFS is our other identity system that supports this set of modern protocols. And today, it only supports one grant type to the ADFS Windows 2012 R2. Only supports one OAuth grant type and WSFED and SAML 2.0. In the next version of Server, we're going to add all of the same protocols that are supported by Azure AD today. So OpenID Connect and the other grant types that we support, OAuth 2 grant types that we support. And this will give you some flexibility on if you're building an application, building it against ADFS, or building it against Azure AD. Now, we do encourage you, because of the trends we see in industry, to be building your application against Azure AD instead of building it directly against ADFS. We would view building against ADFS as an exceptional case where you had a situation for compliance reasons or such where everything had to be on premises. But if you can tolerate the hybrid environment, we do recommend you go against the cloud because it has all of those advanced security benefits I was talking about, because we deploy it on a weekly basis and we can make fixes and we can add features in a much more rapid way than if you're building against the on-premises system. The Azure AD that I've been describing up to this point is identity management as a service for organizations and their employees, if you will. We know that there are people who are building applications who would like to have identity management as a service that does everything for their application, especially if it's, say, a customer-facing application. So let's say I want to sign users in from Facebook or Google, or if I want to have accounts that are specific to this application. We call those application local accounts. How can I do that? Well, we're going to add features to Azure AD as you know it today, that same big scaled system with all of those security capabilities. We're going to add B2C capabilities to it in an offering that we call Azure AD B2C. And it will be able to help sign users up, sign users in, reset their passwords, do multi-factor authentication, all with a customized interface so it looks just like your application, and all using exactly the same programming model that I showed you before. It will also be charged for differently. So today, Azure AD, when you buy the premium capability, we charge on a per-user basis. In the B2C case, we're going to charge on a consumption basis, a very small fee based on the number of users, and a very small fee based on the number of authentications per month that you do. I've seen the way that this hashes out in terms of cost, and I can tell you right now, this is going to be very, very affordable compared to some system that you might be building today and running on premises that's customer-facing. It's going to be extremely affordable, and we're very excited about this capability. Just to give you, and it's coming soon. It's not in preview yet. Just to give you an idea, if you could have a customized sign-in page like we have here for Contoso Airlines. It handles social ID sign-in and local account sign-in. So just local accounts in the Contoso Airlines app. It helps users who forget their password. In the sign-up process, we can gather information about the user and store it in a directory, including extended attributes that you might want. Contoso might want to get the user's frequent flyer number. That's not something that's in the directory today, but you'll be able to extend the directory and add that. You can gather it at sign-up. We store it in the directory. We can send it to you in a claim, or you can look it up using the Graph API. Soon. It's coming soon. This summer. It's coming this summer. There is no information other than what you just saw on this capability. It hasn't been announced yet. It's one of the most highly sought-after pieces of work that we're doing, I'll tell you. Another thing that we're doing, very, very rapidly, only 2 more things left. Another thing that we're doing is we are making it easier for applications that want to sign users in that are both Azure AD users and Microsoft account users. So today, if you do this, you literally end up with different sign-in buttons in your app and 2 different SDKs, 2 different endpoints that you call. We're going to reduce this so that there's one endpoint that you call supporting OAuth 2 and OpenID Connect where you can sign a user in, and we're going to figure out what system they're in, and we're going to give you a token back. You'll only need to use one SDK for this, and it'll just all be streamlined if you want to do this particular action. We're also going to take the registration activity out of the Azure portal so that you don't need an Azure subscription to register your application, and we're going to make that also streamlined, just simplify the number of steps to make it easier to register your app. So let's take a look at what that might look like. I have the fictional Fabricam calendar app, and I've sent a sign-in request to this single endpoint. If Kelly were to enter her work address, then the sign-in page will morph into her work sign-in. If Kelly wanted to sign in to that same Fabricam calendar application with her personal account, then the sign-in page will morph into the Microsoft account sign-in page. And if Kelly has logged into this application with both accounts and returns at some later date, then we'll show tiles that span the 2 systems. So she'll be able to pick, do I want to sign in with my work account or my personal account? And that's all with one streamlined SDK and endpoint for you to access. Last thing, so we're also enhancing the device support for Azure AD. We've talked about this, and you saw this in the keynote yesterday. You'll be able to join Windows 10 workstations to Azure AD. Once you've joined that workstation, you'll be able to sign in to the workstation with your Azure AD account, and then you'll get single sign-on to Kerberos-based on-premises applications that are connected to Active Directory. You'll be able to single sign-on to native applications that use this Web Account Manager API. Vittorio's going to talk about that in his talk on Thursday. And then any web app that uses Azure AD for sign-in, you're going to get automatic sign-in to that as well. So that to-do list application I showed, where I depress the sign-in button, I would just be put right back into the application, signed in with my Azure AD account. We're doing similar work on iOS and Android because, as you know, it's a real pain in the rear to enter your corporate password on an on-screen keyboard in a small device. So what we'd like to be able to do is when a user signs into one application, so they've now their identity is in the system, that if you launch a subsequent application that also uses Azure AD for sign-in, then we will be able to single sign that user on if it is using our framework, so if it's using ADAL, because ADAL will talk to a authenticator application that we will have put on the device that will then mediate all these different sign-ins and allow the user just to pick, oh, I want to sign into this application with this user, which is already in the authenticator, and we'll get that user signed in. It's also the way that we're going to make that device-based conditional access scenario I talked about earlier, where you can say, I only want sign-ins from devices that are not jailbroken or that have a PIN set on them or are encrypted. That will require this authenticator to be down on the device. And we'll build that for iOS and Android, and equivalent capability will also be in Windows 10. Okay, so we're almost out of time. So what do you do? If you want to build an application with Azure AD, first thing you need to do is get Azure AD. If you have Office 365, you already have Azure AD. All you need to do is get access to the Azure AD portal, which means you need to get an Azure subscription. And if you have Office 365, you can get a $0 Azure subscription so that you can get to the portal and you can sign in and you can start playing with Azure AD. We've created a new developer guide that will have all the information you need. Quick start guides for how to write code, locations of all of the libraries, reference material on the protocols that we support, and how to get additional support from us on places like Stack Overflow. You'll find that on Azure.com, and there's a shortcut URL that I didn't get into the slide here, aka.ms/aaddev, A-A-D-D-E-V, aka.ms/aaddev. We'll take you straight to that guide, and we'll continue building that guide out in the coming weeks. You can see Vittorio's talk, BRK 4850, and if you want to see any new functionality that we introduce, you'll see it if you go to our team blog. I have the URL here, but if you search for Active Directory team blog, you'll find it every time on Google or Bing. It's the top hit. So, if you're building an application and it's going to be successful, it will need to be integrated with enterprise IT and enterprise identity management systems. The way that you should do that today to integrate with Active Directory and enterprise identity is through Azure Active Directory. We can provide high security benefits for you. We can reduce the security surface area for your application. We can get your user single sign-on. We can give you advanced ways to protect your application and have IT get control over access to your application. And all of the development is based on standard protocols and open source libraries. I hope that you build an application that works with Azure AD. Thank you.